Before y'all finish your quizzes today, I wanted to make sure we reviewed volume and area. We're going to do a little bit of both. But I wanted us to get what is going on when we have cross sections on a base, and then if we do solids of a revolution. Now remember, if we're going to be perpendicular to the x-axis, we're going to be using dx. If we're going to be perpendicular to the y-axis, we're using dy. The first thing for cross sections is to know the area formula for your cross section. Be it that we have squares or semicircles or triangles or whatever it might be. Then we have to figure out the length of that cross section. Usually that's taking that bigger curve minus the smaller curve, whichever curve's on top minus the smaller. That's going to be that side of your cross section. The solids of revolution, well, that was a little bit easier. Those were all circles, pi r squared. We just needed to know if it was a full circle or if it had a hole in the middle. That's what they mean by washers or discs. Washers would have a hole in the middle, kind of like our lifesaver did. So let's look through this little review. So let's say we had a region R bounded by the curve f of x equals x squared minus 1 and above by the curve x plus 1. So I always like to start with a little sketch. X squared minus 1. That would be up 1, and then it would kind of do this. This is a quad. Oops, minus 1. Oh, I missed it. Minus 1. That shifted down 1. And then it would go like this. The line x plus 1 is the one that starts up here and goes forward like that. Okay, so there's the line x plus 1. So I know that's the top and then that's the bottom. So let's kind of review with area first. I need to know the x values at each of these points so I know the boundary for my region. Well, you could use your calculator for those, or we could set them equal to each other and solve it. X squared minus 1, x plus 1, well, this one's pretty easy. That's 1 through negative 1. But let's double check where the other side is intersecting. So when I get to the guess, I'm going to move over here, and I think it's about 2. Oh, it is. Good. So here's x is 1, and this is x is 2. Good. So we know our boundaries to find the area. So the area would be going from 1 to 2, top minus the bottom. So x plus 1 minus x squared minus 1 dx. Now I'm going to go ahead and let's do this one by hand to remind ourselves. That's going to be x plus 1 minus x squared plus 1. So that's x squared, negative x squared, plus x, and then we have a 1 minus a negative 1, that's going to be a plus 2. If we're taking the integral, we're finding the antiderivative. So add 1 to our exponent and divide by the new exponent. Divided by 1, which I don't need to put. And we're evaluating from 2 to 1. So you would plug in your 2 minus plugging in your 1. That's negative 8 thirds plus 4 divided by 2 plus 4 minus plugging in 1 for x. So negative 1/3, 1 squared over 2 plus 2, and so forth. Remember, you can also do it in the calculator. Let's remember where I put these. This one was y1, and this one was y2. So if I wanted to use my calculator, alpha f2, the integral from 1 to 2, y2 minus y1. Okay, so alpha f4, y2 minus y1 dx. 1.167. 1.167. Now, let's review those cross sections. Cross sections that are square. So we're going to make a whole bunch of squares going across here. So a square, the area of each square is the side squared. Okay, so side squared. Okay, so that means that distance between here and here squared. Okay. So I can go in here and go alpha f2, integral from 1 to 2. And a lot of times they'll actually ask you just to set it up, which is kind of nice. So I would be taking y2 minus y1. Oops, not negative 1. We're trying to square it. Oops. And that is dx, because it is perpendicular to the x-axis. So I get 1.7. Semicircles. Okay, so we got semicircles. So that's going to be, the radius is half the distance. So half of that distance squared, pi r squared. So half of that squared, but we're only doing half a circle. So it's the area of each of these is half of pi r squared. But our radius is half of that distance. So if I looked at that, let's just call that the distance between the two functions. So that would be 1/2 pi, 1/2 that distance squared. So that would be 1/4, 1/8 pi, that distance squared. So really, I'm going to be taking very similar to what we had there, 1/8 pi from 1 to 2 of x plus 1 minus x squared minus 1 squared dx. So since I just found the square cross-section, I can just multiply that times pi and divide by 8. Oh, that's nice. 0.668. Now, if it was an isosceles right triangle with the hypotenuse in the base. Ooh, that one's different. So the hypotenuse is in the base? Oh gosh, okay. So that base is my distance, right, between the two functions. And it says this is a, okay. So it's a right triangle. Now I know that an isosceles right triangle at side root 2. Okay, so to work backwards, this would be d divided by the square root of 2, right? Yes? And if I look at this in a little bit different way, I turned it, this is the height and the width and the height and the base of that triangle. Well, I know that area is 1/2 base times height. So that's going to be d squared. Square root of 2 times square root of 2 is 2 times another 2, so that's 1/4. So 1/4 d squared. Well, d squared was this one. Gosh, so that's 1/4 from 1 to 2 of x plus 1 minus x squared minus 1 squared dx. Well, okay, it was 1/4 of that, so 1.7 divided by 4, 0.425. Now, we didn't have this on this worksheet, but I'm going to add it in there. What if we took that region and spun it? Spun it around the x-axis. So you'd get kind of a weird figure, wouldn't you? Wait, this one isn't working out. Let's skip that. Okay. I'm sorry about that. They wouldn't have rotated around the x-axis. We probably would have rotated it around the line y equals -1, so that you would have this interesting figure here. See, I was on the right track, but I kind of got lost. It's kind of like a yeah, this is kind of like a little solid vase. It's got an opening in the middle. So if we thought about what that figure would be, what we're going to have are these open middle discs like this, with a hole in the middle right there. So we have an outer radius and a lower radius. Now our outer radius is made up by that line, x plus 1, minus our line of rotation, which was -1. So the big R is going to be x plus 1 minus a -1. Oh, okay, that's x plus 2. And let's call it little r for the inner radius. That's this curve minus our rotation. So x squared minus 1 minus a -1, which turns into plus 1, so that's x squared. So you'd have pi, the large radius squared minus the small radius squared dx. Because we had that larger circle minus the smaller circle. So since those are different functions, I would go in and go from 1 to 2 still. Oh, I forgot the pi. Let's put that out here. So second insert pi. And then I need to do r, which is x plus 2 squared, minus little r, which is x squared squared. It's going to be x to the 4th. And that is dx, because we're rotating horizontally. That'd be 19/4. 1.268. Notice that when you're doing the volumes of revolution, it actually gets a lot bigger than what we get with the cross-section, because we have a whole figure that's doing the revolution. So the last example, y equals e to the x, and y equals x plus 2. I'm going to put this one in y1, and this one in y2. E to the x, and this is x plus 2. So there's e to the x, and x plus 2 is going through there. I'm going to assume decimal. See if we see it a little bit better. I do. That looks really good. So we have this region going like this, and it's going from here to there. Okay, so we're trying to find, so this is the y2 up here, and this is the y1. If we have square cross-sections perpendicular to the y-axis, so if we're going to the y-axis, we're going to need to rewrite these in terms of x, in terms of y. So we need to solve for x. So that first one, y equals e to the x, well, if I rewrite that, that's x equals natural log of y. And the other one will be y minus 2. That's easy. And we're going with respect to the y-axis. So I need to know, it'd be really nice to know the points here and there. So I'm going to go into the calculator and find those intersections. Now remember, in your calculator when it says guess, we need to get really close to the point that we want to look at. So this point is negative 1.8414, and the y value is 0.1586. We'll go 4 decimal places. The other point, whoops, is way up here. Looks like it's at 1. I hope so. Nope. It's at 1.1462 and 3.1462. So if I'm doing this with respect to the y-axis, then I'm going between these two y values. Now there's square cross-sections, so that's the bigger one minus this one. So the curve would be natural log minus the y minus 2, which will turn into negative y plus 2. Cross-sections are square, so that length squared, dy. Now in the calculator, which is where I'm going to put this, we're not going to put in y, we're just going to use x. So, whoops. I hit second, not alpha, that's right. Integral from 0.1586 to 3.1462. Natural log x, the calculator doesn't care, minus x plus 2. Uh-oh. I should have had parentheses around all of that. So I need to insert parentheses, go down past the x plus 2 and put another parentheses, squared, because a square, the side squared. And it gives me 1.545. Now if they're equilateral triangles, and it says perpendicular to the x-axis. Okay, so now we're going from the x's. So negative 1.8414 to 1.462. So the x-axis. Now, to find the area of an equilateral triangle, it's actually square root of 3 over 4 sides squared. So the square root of 3 over 4 would go out here. The side, oh, is not that. It's our y's. So which one's on top? It's y2 minus y1 squared dx. Okay. So, square root of 3 divided by 4. Integral from negative 1.8414, 1.462. We need to open parentheses, x plus 2 minus e to the x squared dx. 0.699. Semicircular cross-sections perpendicular to the y-axis. So semicircles, we just did that a second ago. I think that was pi over 8 times that. Rectangular cross-sections perpendicular to the x-axis such that the height of the triangle is 3 times the length of the base. Well, gosh, instead of doing square root of 3 over 4, we just put 3. I hope that helps getting the hang of those cross sections again. So I need you to finish those quizzes and turn them in, and then work on, it says the volume practice sheets that I handed out a long time ago. I've left extra copies. This is to turn in. So you do need to work through all of those.